Hello all, welcome to one more video lesson of this VariCAD 2016 training course. And the topic for this lesson, it is transforming solids in 3D. So I've done a little and very easy assembly with two solids, this blue one, bigger one as a base, and this red one, which is going to be the solid which we will use to do the transformations. I want to show you a very important part of the software, which is insert a solid on the 3D side and different possibilities to translate it and rotate it and so on, transforming the solid. So to do this command, we must go to this function here, which is called transformations, copy, edit, constraints. Okay. Let us use this one, and now we'll choose the solid, and the solid we will choose, it is the red one. We could see these same options and commands if we were inserting a solid, but we will use this example of something already inserted in the 3D. So choose the solid and do the OK. And now the important part of this lesson, it is this toolbar that is called 3D location bar. And to change and transform the solid, we can use several things inside the environment. One of the things that in fact resumes almost all these options are the axes, okay? And the axis, we have several possibilities according to the place we click. So we can click for translations on this side of the axis, on this front side, and this will act in one way. If we click the inner side of the axis, it's different, and these two are for translations. And we have also the same for rotations. This bigger arrow will do one kind of rotation, and this smaller one will do another kind of rotation. I will leave this to the end because seeing the options here, you will get the notion, and then it is basic, this part. Just see one axis, so there is no need to repeat the same things for the other axis. The first thing to notice, it is when we insert one solid or change one solid inside the 3D, the solid has already one base point, which is shown here, okay? This is the intersection of the axis. And you can see by the colors which axis it is, the X, the Y, and the Z, okay? So let us do the example first for the X axis. So the first option, it is translate along X, so along the red axis. I click here, and if I say a distance, for example 50, I do the OK, and it will move 50 millimeters, or a distance. I will go back, okay? Or for example, in this case it is dynamic. So you see, dynamic mode, okay? Back again. So by distance or dynamic, which in fact it is the same by distance. Now some of the options, if we use one side, you cannot use the same option at the same time. So by distance, you see the same board, back, or here dynamic, the same, okay? So choose the solid again. So these options are done. Here you have by distance defining a vector, or dynamic defining a vector. It's the same, the only difference it is you click in one of these options, then we can define a vector for translate. For example, with all these options, 2 points, then you can click this point, for example, and this point, the vector is here, so defining vector, or another distance. And for all these dialog boxes, when you have one value, positive or negative, you can change the value just clicking here. So saying the vector it is defined, so you can use it to make the translation. This is for translations. This is the same for rotations. Again, on the X, rotate by angle, and there is a dialog box for the angles. We can use some of these predefined values, whatever you want, with a minus or plus. For example, the 45, you must see also the direction of the arrow, which indicates you the positive side, and okay, it is rotated through the red arrow, which is the X. Okay, coming back again, this is the dynamic mode. Okay, the point, it doesn't matter, just to grab, and you see dynamic. Besides these options, we have another thing, which is an additional rotation. This is more interesting for constraints and parameters, so basically it will do another rotation with a value, because if you click here you just give an angle also. And the same, besides these normal options, we can rotate defining the axis. So for example, again, I can define the axis as being this, and okay, I will rotate through this new axis defined. Okay, now we have the possibility to define the directions as defining the vector or as a predefined vector. Okay, basically it's almost the same, but the idea it is, for example, for the X, I have this direction now in the solid, and I can define again the X will be here, and you see the solid rotate, so now I can insert a distance, and the predefined vector will use what was defined previously, so not too complex. Besides these options, we can position the solid by some other solids in the 3D environment. For example, positioning the axis of this solid according to one other solid that you might have in your environment. I don't have any solid different, but you see, if I click or if I go over this blue solid, you see the axis here in the corner. They have the same orientation, so nothing will be done different. Okay, or the same, instead of a complete solid, for one part of the solid that could be, for example, one of these things here, but you see that the axes have the same orientation, so again no difference on the final result. And still according to the world coordinates, which also are the same, so no difference. But this is these are other possibilities to make the definition of the axis. Then we have other ways to position the solid according to the normals and the plans. For example, again, for the X, I can position the X-axis along a normal and locate it on a surface. For example, you must see I'm leaving the solid on the normal position, and you'll see that the red axis, which is the X, it is pointed to the right. Then if I go to my mouse over the surfaces, you see the position of the solid is changing in such a way that the x-axis of the inserted solid will point on the same direction as the axis of the plan I'm choosing, okay? And it will be placed on the point I click, which is on the surface, on the patch, as they call it. The exact same position, but now instead of being along the normal, against the normal, okay? You see, the exact same plan, now it will stay on the opposite direction, okay? And again, axis to normal or against normal. This time not positioned on the plan. Or, for example, it will stay on the position it is, just switch the axis according to the plan I'm choosing. The same for the others. And finally, we have two options to position this plan to plan or normal to plan. First, plan to plan. I can choose a plan from the solid I'm working with. So again, I can choose, for example, this plan, which is the one that the X is pointing. And now I can say point to this one, and it will be plan to plan. Or normal to normal, this one, which is the green one, and pointing to this, so it will be opposite. So several options to make these positionings. Besides these directions, we have options to position the solid in points. And for example, saying the point, which is the base for the solid, it can be inserted on an endpoint, okay, on a center of gravity, midpoint, whatever, you know, all these options, on a certain dx, dy, dz, or on a specific coordinate, or between a specific distance. All these options are quite similar to the ones you've seen on the 2D side, okay? Or nearest from some point, you know, all of this. We have some of them are a little new and specific for this 3D side, like this one, intersection between a line and a plan. So, for example, I can say the line, it is this one, and the plan can be this one. So, in fact, it is this corner. Okay, it is okay. Or the same, an axis and the plan. Okay, I don't have a round thing here to choose an axis, so I cannot do it here, but basically it is the same concept. Also interesting in these options of the positioning, it is the possibility to define a new insertion point instead of the one I have. For example, if I click in this option here, I can choose a new point on the solid, okay, and the axis move, and now I can, for example, more easily choose another point, okay. I have also the possibility to choose an insertion point of a solid or a part of a solid, okay. For example, choose of one element, okay. To finish these commands, what we have more? We have the possibility, all of these moving around or transforming, either rotating or translating we can define the increments in dynamic mode, okay, and the translation in this step and the rotation in this step. So we can use this, for example, rotation step 2, okay. You can see, sorry, made a mistake. You can see here, for example, that it is moving, okay, 2 degrees each time. So the step, it is correct. Besides, we have two nice options also regarding the copies. So I can say, for example, this solid, I can do a copy, and I can leave a copy here and just say OK. And now I can move it around, okay, and insert it again, just saying OK. But I've made a copy here. Or I can do a little different option, which is identical copy. And the identical copy, it will create a link between the original and the copy in such a way that when you change one of the elements, all of them are going to be changed. But in terms of the transformation, it will do the same, okay, because in the end just insert another object, but the type of link, it is different. The copy, it just make you a copy. The identical copy makes you this link between elements, okay. Finally, besides these options here, we have also two little options down where we can define, when inserting a solid, constraints and Boolean operands. I will leave the constraints out because we still did not see the constraints. But for example, in the Boolean operation, if you click here when inserting, and the operations, you know them already, we've seen in one of the previous lessons. As an example, we can insert and add the solid to another one. For example, add, and we can say add the solid to this one, do it again, choose it, add it. So you see now I have one solid. And the purpose of this is when we do the inserting, we can do in the same command without leaving it. We can do the Boolean operation being an addition, subtract, or intersection, okay? We can do all these operations in the same command. So this is a very important topic. I hope the explanations were clear. This is very important because this is the base of understanding these possibilities of moving around the solids on the 3D side, and it is the base to work with assemblies and positioning correctly the solids around here. So most of the people when start to work in VariCAD have problems because basically they don't understand how to work with these transformations. I hope it was clear. For any help, please send us an email or place us a comment in the video in YouTube, and we will reply to all the viewers of these videos.